Right now, the sun looks permanent, unstoppable, guaranteed. But imagine this. You wake up tomorrow, and it's still night. Not early morning darkness, not clouds, not an eclipse. The sun is simply gone. No sunrise, no warning, just darkness. At first, most people wouldn't panic. Street lights are still on. Cities are glowing. Phones still work. The world feels normal. For about 8 minutes, because that's how long sunlight takes to reach Earth. If the sun vanished instantly, we wouldn't know until 8 minutes later. And then the sky would go black. Not dark blue. Not sunset orange, black. Stars visible in the middle of the day. That's when panic begins. Within the first hour, temperatures would start to drop, slowly, not freezing instantly, but noticeably. Solar energy drives surface warmth. Without incoming radiation, Earth begins losing heat immediately. Air traffic control would be overwhelmed. Pilots rely on visual positioning and solar orientation cues. Sudden permanent night would cause global rerouting. Airports would experience chaos. But the real threat isn't in the sky. It's in the power grid. Solar energy powers more than you think. Renewable systems would fail instantly. Energy demand would spike as heating systems activate worldwide. Within hours, weaker grids would begin collapsing under pressure. Rolling blackouts would spread. Cities would dim. Now we reach hour 6. Temperatures drop several degrees. Wind patterns shift. Because the sun doesn't just provide light, it drives atmospheric circulation. Without solar heating, pressure systems begin destabilizing. Weather becomes unpredictable. Storm systems stall. Ocean surface temperatures begin cooling. Marine ecosystems feel it first. Phytoplankton depend on sunlight for photosynthesis. They form the base of the ocean food chain. No sunlight means no energy production. It doesn't collapse in one day. But the clock starts ticking immediately. By hour 12, global average temperature may drop significantly in some regions. Deserts cool rapidly. Tropical zones feel unnatural chill. Social media explodes with theories. Governments issue emergency statements. Astronomers confirm the impossible. The sun is still there, but it has stopped emitting visible light. No solar flores, no radiation spikes, just darkness. And that's when fear turns existential. Because if fusion inside the sun has stopped, that means something catastrophic has occurred at a stellar level. Now, hour 18, surface temperatures continue falling. Not ice age levels yet, but enough to stress crops and livestock in vulnerable areas. Solar-powered satellites begin experiencing power limitations. Backup batteries activate. Communication networks strain. Financial markets suspend trading globally. Psychological impact intensifies. Humans are not designed for total planetary darkness. Circadian rhythms begin failing. Sleep cycles collapse. Hospitals report spikes in anxiety-related emergencies. Now we approach hour 24. A full day without sunlight. Average global temperatures could drop several more degrees. In some inland regions, frost begins forming unexpectedly. Power demand is at record levels. Fuel reserves are being burned rapidly. Air quality worsens in dense cities due to heating emissions. And then, at the exact 24-hour mark, light returns. Slowly, at first, a faint glow on the horizon. Then full sunrise. But it's not relief. Not entirely. Because scientists now face a terrifying question. What caused it? The sun generates energy through nuclear fusion in its core. Hydrogen atoms fuse into helium, releasing enormous energy. That process has been stable for 4.6 billion years. It cannot simply turn off for a day. If it did, it would imply either unknown stellar physics or external interference. But let's assume the Sun truly stopped producing energy for 24 hours, even briefly. The internal balance between radiation, pressure, and gravity would shift. If radiation drops significantly, gravity begins compressing the star. The core would contract, temperature would rise, and when fusion restarts, it could restart violently, potentially releasing intense solar flares, coronal mass ejections, radiation bursts aimed toward Earth, meaning the real damage might not occur during the darkness. But after the light returns, satellites could fry, power grids could overload, auroras could appear globally. Communication systems could collapse under electromagnetic storms. And here's the most disturbing truth. Even if Earth survived the 24 hours physically, trust in cosmic stability would be shattered. The Sun represents permanence, predictability, foundation. If it can fail even briefly, then nothing in our universe feels guaranteed. Now, take a breath, because here's the reality. The Sun cannot simply turn off like a light bulb. Its fusion process is self-regulating and stable over billions of years. If visible light disappeared, it would likely mean atmospheric interference or unknown cosmic obstruction, not actual stellar death. But the thought experiment reveals something important. Earth is entirely dependent on a single star. Every breath you take, every plant that grows, every drop of rain exists because of a continuous nuclear reaction happening 150 million kilometers away. And if that reaction paused, even for just one day, civilization would feel it immediately. Look at the sunrise tomorrow. It feels routine, automatic, certain, but it isn't magic, it's physics. Delicate, precise, balanced physics. And in a universe this vast, even the most stable systems deserve respect. Because sometimes the scariest question isn't, what if the sun exploded? It's much simpler. What if it just stopped shining? For one day,